Hi, we've just come up from the ground. I don't know why. We're doing graphs by the looks of it.
Yes, very
exciting.
exciting.
So we're plotting graphs? Or?
No, we are doing that really annoying question. The one where you have to match an equation to a picture, and most of you
have
just
six
go,
pictures, don't they? Have 6 pictures.
Yeah, and then they have
equations.
Yeah, and then or they just give you 2 equations, and you have to pick from the 6.
Which one? Okay.
And most of you go, I'm just going to pick these 2 letters because they're my favourite letters, and you don't actually give the time to think about it. So,
apparently.
No, I really do believe that.
Okay.
So straight lines.
Straight lines.
Have I picked the right thing?
Yeah, that'll give you a straight line. You can change the colour though. Do you want to change the colour?
Yeah.
I don't know. That.
Yeah, yellow.
Yeah.
Why not?
Go away.
Okay. So I'm going to draw a straight line here.
Okay.
And then I'm going to draw another one in a different colour.
So I'll make it really straight.
Yeah.
Is that nice?
Yeah, I think
Lovely.
so. And
a different colour?
Yeah, I want a different colour.
There you go.
And I'm going to draw.
Ooh.
I'm going to draw one there.
That's beautiful.
I think that's quite good.
Pretty good. That's pretty good.
So these are average Joe straight lines. These are the basics. Okay. Where we have our x-axis and we have our y. So we've got our y here and we've got our x.
Beautiful.
Okay. Now this line is crossing at a certain point on the x-axis. Let's call it. It's crossing at -4.
-4. I'm thinking
-4.
-4.
Okay. So it's going through -4. Every single coordinate on this line would have an x coordinate of -4.
Okay, so this would be -4, 0, -4, 1, -4, 2, -4, 3, -4, 4, -4, 5,
and
-4,
so on.
-1. I've said -4 a lot.
Yes. And therefore x is always -4, so x equals.
So that's how we would describe that line, because everywhere on it, and it is the only line where x is -4.
And then we've got our other line here, okay, and we're going to say that this one's hit about 3.
3, yeah, y equals 3.
So therefore, because it's going through the y-axis at 3, and all of these points would be 1, 3, 2, 3, 3, 3, 4, 3, y equals 3. So these are your easy straight lines. If you see that one, you know that that's a straight line. You know it's either going to be x equals or y equals, and that's easy. Okay?
Nice.
We're going to move on now, and we're going to draw another one.
Y equals mx plus c, another straight line.
Another straight line.
Yeah.
And I'm going to go for this kind of green colour.
Nice green.
And I'm going to go like that. Okay, so here we have our straight line. I'm going to say it's
2x plus 5.
Yeah. This is y equals 2x plus 5. Let's call it that.
So we call it.
You're in the straight. There you go.
Thank you.
So this one can be identified. This number, as you know, is the y-intercept. So it's crossing at about 5. It's crossing in the positive, so you know that that's going to be a positive number. It's got a positive gradient.
Okay, of 2.
Because it's increasing, it's a positive gradient, and it's about 2. If it was getting steeper, then the gradient would get bigger.
3
if
or 4
if it
5.
would become smaller, a smaller number like a fraction or a decimal, then it would be coming the other way.
So when it goes the other way, it's going to go down to 1x or half x or quarter x.
Yeah.
Yeah.
As long as it stays positive.
As long as it stays positive.
And then as soon as it switches over,
it becomes negative.
And it's going the other way, and you can kind of link this to your kind of correlations, positive correlation, negative correlation.
Okay.
This one has a negative gradient, and I'm going to say it's minus 2 because that's about.
Well, it would be -1/2, wouldn't it?
Minus half, yeah.
Perpendicular.
Y equals minus a half x, and it's going for the negative. Yeah, about -4. Okay, so it's going for a negative for its y-intercept. It's got a negative gradient because it's going that way, and because we've got this perpendicular, you guys in height,
I should know this.
You know that it's the negative reciprocal. Foundation, you don't have to worry about that.
No.
All you need to know is that if it's going that way, it's going to have a negative gradient.
Negative gradient and a negative y-intercept, because clearly it's that -4.
So these are the type of things that have to go through your brain. If you see a diagonal straight line, you should be looking for an equation which looks like this: y equals something like that. No powers involved, no squares, no cubes, no nothing. It's just y equals something, x plus something. Now we come into our powers.
Quadratic. So for a quadratic graph, we're looking at something, well, probably y equals x squared. Would probably look
Lovely.
like that. Okay. I could move that up or down. So I could take the whole thing. Let me see if I can do this magically. Let's see. Oh no, unfortunately it won't do that. But I could move this up. And if I moved it up so that this point here went up to 1, it would become y equals x squared plus 1. And if I moved it to 10, y equals x squared plus 10. And if I moved it down, it would be y equals x squared minus 10.
Okay, so it could look like up here or down here. Okay, and this one is all positive. If it's shaped like a U, then it's a positive quadratic.
It's a smiley face because everything's positive.
Yeah.
If I turn it upside down and make it a sad face, which I'm going to do with a different colour, so it might go, oh actually no, I'm going to rub that out first. So let's just eradicate all of that. And let's do a negative version. Let's say it was like this.
Okay, so that would be your y equals minus x squared, but it's hitting about 2.
2
so therefore it's plus 2.
And again, if I drag this down, it would still be y equals minus x squared, but then it would be perhaps at minus 4.
Yeah. Okay, so you've got your positive, which is like this, and your negative, which is like that.
If I put a number in front of the x squared, it will change the overall shape.
Yeah.
But it will still be similar to this. In fact, if I put a 2 in front of it, it will just bring it in a bit tighter.
Yeah. Okay, so just to explain what Miss Coleman was saying, we've got 2x squared, would be the same sort of shape, but it's going to be a bit skinnier.
Yeah.
Okay, but you're looking for that shape. It's never going to be that difficult. It's all about the general shape of the graphs that you are supposed to be aware of.
Yeah, next one.
Cubic.
Okay. So cubic looks a bit like, and a bit more difficult to draw. It's just a flatten off and go like that. Y equals x cubed.
Yeah.
And again, if I add or subtract another number, it will shift this up or down. This point here. So y equals x cubed plus 2 will look very similar, but will go through at a different point.
And this one can have so many things added to it. Now they're not going to be that crazy, but they could give you something like that. Okay. Unlikely, but if they did, it still has this general shape. It's just kind of skewed a bit more, kind of in the way that it works.
So that general shape comes up, flattens off a bit, carries on going.
Yeah, and so it just skews it, but that is the general shape. Okay, this guy. Okay, this is our inverse. Now, this is how you recognise this one. Okay, can I divide by the number 0? No. The answer is no. Okay, so where you see this one, it will never ever touch the origin. Okay, this one will never touch the origin. So if I was looking at the first one, okay, my positive one, my y equals 1 over x, it's in the positive and the negative which is also positive. Okay, because negative makes positive, positive makes positive. Okay, now if I was looking at this one down here, my negative inverse, it's going to be in the positive negative and the positive negative, because you know that they make negatives. Okay, because if you do positive plus negative.
So if you learn the first one, this is just the reverse of it.
Yeah, absolutely.
To remember.
And you can remember it through your positive negative rules. Now, squared is slightly different again, because it is only in the top half of our graph. Because any number squared is positive, so it's only going to be in the positive half of our graph.
You're squaring, effectively you're squaring this, it stays the same, it just becomes bigger. You're squaring this, it's a negative, and when you square a negative,
it becomes positive. Okay, so you'd only be in the top half of the graph. Okay, and that is that one.
Okay.
I've realised we have forgotten one, which we might
We've forgotten one, we'll come back to it in a minute. Okay.
This is our lovely one.
We quite like this one, I'm just going to
You
find
will recognise
shape.
this one.
Here we are, this is one.
Yay! This is our circle graph, okay? And whatever number you have here, so let's say that you had 5 here, and 5 here, and minus...
Sorry,
minus
All
5
working
there,
at the same time. Stop it.
and minus
Minus
5
5.
there, okay, that
Point.
would be the graph 25 equals x squared plus y squared, because it is the radius squared, and the radius is the centre point to the outer squared.
That's easy enough, isn't
Okay.
it? If this was 6,
It's 36. Okay, and the circle one is easy to remember. If you just remember that it's the one that has the x squared plus y squared, you will remember that one.
Sine, cos and tan, my favourite graphs of all time. I always start with sine, I don't know why, just find it the easiest one.
Sine's the best.
So sine, I always remember starts, let me get the right colour, starts at 0. And then each point goes up to 90 at 1, comes to 0 at 180, then carries on going down to -1 at 270, -1, +1, and back to 0 at 360, which is here. So actually looks a bit like this.
Beautiful.
Not quite as beautiful as I wanted, but beautiful enough.
I think that's a lovely
You
sign.
think it's a lovely?
I think it's really lovely.
I'm going to draw a cos on top of it, because really it follows the same sort of pattern. It just starts in a different place. So cos starts at 1. So sine starts at 0, which is why I go for it first. Cos starts at 1. And because it starts at 1, it has to only come down, so therefore it goes to 0 at 90, -1 at 180, back up to 0 at 270, and back up to 1 at 360. So it looks a bit more like that.
Lovely.
Okay. Tan is
It's like we kept the fish.
tan is just different. So tan special starts there and goes to infinity. So it would look like just carries on to infinity. And at infinity it's also at minus infinity, so it actually is down here as well. So it kind of comes back into the game. Then off it goes to infinity again and comes back again. This point here, do you know what it's called?
Asymptote.
An asymptote. There we go. That's it. You have to memorise them. Try and do it. It's easy enough.
They don't also look anything like the other ones, so
is,
they should be quite easy to remember. The
One we
only
missed.
one that I missed was
Yeah.
the exponential.
Which is really what the tan graph is. But yeah.
So,
Let me go for that.
this one's quite simple. He just increases and increases and increases and keeps on increasing.
You want blue? Okay.
So it starts here.
Yeah.
Oh,
Could start anywhere.
Could start anywhere.
Could start
But
there.
basically, and it works like bacteria.
Well, and when the current crisis is over, and it's a bit more PC to do so, we'll probably use
We'll
lots
probably
of
talk
examples.
about these
We'll probably
sort
talk
of
about these graphs.
Okay, but that one just keeps going up and up and up and up and up and up.
Yeah.
Okay.
Done.
Done. Lovely. So what you have on show my homework, you don't have any Sam learning today, you only have show my homework. So on there is a foundation matchup and a higher matchup. We have all of these graphs and all of their equations. You need to cut them all out and you need to match them all up. Now if you don't have glue at home, don't worry, just match them up yourself. It's an exercise for yourself. If you do and you can stick them all in your book, that would be lovely. Or if you've got a nice big piece of paper, you can stick them all in there,
make a poster for yourself.
But we aren't putting that on you, it's whatever you have available to you. Okay, that's what you need to use. That's not essential shopping.
Okay. We're done. We'll come back tomorrow.
We're back tomorrow.
Is it hats tomorrow?
It's hats tomorrow.
Hats tomorrow. Look out for the hats.
Wear your hat as you watch our video.
Oh, that's a good idea. Bye.